Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. Can make me move. Can make me
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
What does perfect even mean? Is there even such a thing? Ooh, can we switch up all the rules and imagine a utopia? Darling, I'm just so fed up with these expectations. They keep weighing me down. My heart is begging me to get the hell out of my head. I'm
empty town. I'm searching for the lost and found. But you don't care, you're unaware. Keep moving like the scars aren't even there. It's in the air, like a blazing flare. Just stare, 'cause the flames will burn us. I thought you were the one for me. That's why I gave
Good
you
afternoon, everybody.
everything. Crossed by the stormy sea.
Day before exam.
Meant the world to me.
What do we do?
Kiss your head when you cried for me.
Some papers. Second. Good. Alright, so let it tell man. I want to do some topics. I was getting some requests to do some topics, so I'm gonna do some stuff. Good afternoon, Sammy. Where's the scene? So here what we're doing, right? First things first, I got a question for SVA. Somebody asked, how do we use SVA? So that the first thing I'm gonna run through. SVA, this is for kinematics. Next, I want to run through solving inequalities and developing a range of values. Next, it's just a quick thing I do now. What else? All you had to tell me. We go try and do about as much as we can do. By 6 o'clock, I would like to look up if we have the time and the need to go over, we go over and we will go how long, because I know exam is tomorrow. All you had to tell me. Give me some input. What else all I want to do? This is kinematics. Good days are here. Oh god, after 3 is 5, yes? I need KFC back in my life. What else? We have well, the main factor here, I'm logs and all that thing will be easy. We have, where's the next challenging topic, boy? Any trigs? 30 trigs. Alright, look, Sammy say trigs. I don't see no trigs will take a while, right? With the quadrants, so solving trigs, right? Real easy stuff. Concept simple to follow. Just pay attention, that is all. You could always go back and review, and just keep doing questions if you want to, right? Vectors and intro to calculus. Well, vectors is a small thing, and intro to calculus, but calculus is a big topic, you know. So actually, I say the same thing. All right. So let me start with that. I'll go try and do it in order. So let me do the inequalities first, because I'll go introduce the calculus, then run into kinematics. Then I will do trigs, and the last thing we will do will be vectors to finish off on a light note. Alright, so solving an inequality. Now everybody's supposed to know how inequality does look, right? And we're dealing with quadratics here. Now let me just take, for example, a simple linear inequality. Let me say I have 2x plus 6 is greater than 4. Move the 6 across. 2x is greater than 4 minus 6. 2x is greater than minus 2. Divide by 2. And x is greater than minus 1. This means any value of x that is greater than minus 1, it's supposed to satisfy the inequality. So if I pick a value of x greater than minus 1, let's say 0. If I pick 0, that's supposed to satisfy the inequality. So minus 1, an open circle in this direction here. Any number to the right hand side of minus 1 supposed to satisfy the inequality. So we can do a test. So we can test x is equal to 0 in the original inequality. I will get 2 into 0 plus 6 is greater than 4. I get 6 is greater than 4. It making sense. When it doesn't make any sense is when we test a value that is not in the range of solutions. For example, if I test a number on the left hand side of negative 1, let's say negative 2, I will get my inequality not making mathematical sense. 2 into minus 2 plus 6, it's supposed to be greater than 4. That is what the inequality says. We get minus 4 plus 6 supposed to be greater than 4. I get 2 supposed to be greater than 4. This makes no mathematical sense. Right, my handwriting are just hustling, right? But you know what I say. The first one, it making sense. So there's a concept and the premise I want a little to use going into solving them when you have a quadratic inequality to solve. So let me make up one. Let me say I have a inequality that says 4x minus 3, let me put minus 8, over 2x plus 1 is greater than 0. I put greater than or equal to 0. Now, the first thing whenever I have an inequality that looking like this, we have it looking like a fraction. I have a linear on top and a linear below. Every single time, we multiply by the square of the denominator. So I multiply by 2x plus 1 to be squared every single time. I'm not going into why, just do it. If you have it in this form, so if I have 2x plus 3 over 6x minus 9, if I have 4 plus 3x over 6 minus 2x, and I have some inequality sign and a 0 and a 0, multiply by the square of the denominator every single time. When we do that, I kind of getting rid of my denominator. So I'll have 4x minus 8 multiplied by 2x plus 1 squared all over 2x plus 1. Remember, if I do it on one side, I do it on the next side. Greater than or equal to 0 into 2x plus 1 squared. The denominator will cancel with one of the expressions on the numerator. And well, 0 by that is 0 on the right hand side. So I end up with a equation, well, an inequality. And if you notice, these two brackets here, this is the final form when we factorize a quadratic. It just so happens the question they gave us, it wasn't in the form of a quadratic, so we didn't have to do no factorization. If it was in the form of a quadratic, you would have had to factorize, and eventually we will reach at this stage. When you factorize, we get a bracket by a bracket, and we reach this stage. From this stage, this is what I like to do. I'm ignoring my inequality sign. However, I am paying attention to the nature of it, whether it's strictly greater than, strictly less than, or whether it has an equal sign attached to it. This inequality sign in my question will determine the nature in my answer. The only thing I'm concerned with is whether it have an equal sign next to it or not. That's the only thing I'm concerned with. I'm not concerned with the direction. When I solve this, I put each bracket equal to 0. Before I do that, I say let 4x minus 8 into 2x plus 1 equal to 0. So I have 4x minus 8 is equal to 0, 4x is equal to 8, and I have x is equal to 2. So I get one solution. I change the inequality to an equation, and I get a solution. Or I have 2x plus 1 is equal to 0, and I have x is equal to negative a half. So I get my two solutions. Once you get your two solutions, represent them on a number line. Draw your number line nice and long. Represent your two solutions. This fella is minus a half, and this fella is 2. By representing the two solutions on the number line, I separate my number line into 3 parts. I'll say let this fella be part 1, which is before minus a half. I'll let this fella be part 2, which is between minus a half and 2. and I let this fella be 3, which is greater than 3. Now, obviously, the first section, we have to write down what the range of values is for that section. For the first section, it's x is less than minus a half. Notice, I'm not putting in less than or equal to, I'm not putting in greater than or equal to, because I'm working with my number line. Just pretend when we're working with the number line, we're fresh, right? We're just working fresh. We're not trying to figure out and incorporating this inequality sign in my solution as yet. For the section 3, it's strictly x is greater than 2, because all other values x is more than 2. So x will be 3, 4, 5, and so on. The middle now, if I have x is, the middle will be x will be greater than minus a half. If x is greater than minus a half, then minus a half is less than x. And that's on the left hand side of section 2. On the right hand side of section 2 is x is less than 2. In the middle now, x is less than 2. And this is how we combine the two range of values to get my range of values for section 2. From here, this is all I want everybody to do. Just like how we perform that test for a regular inequality, I can perform the same test for a quadratic inequality. So every single time I will test x is equal to 0, unless 0 is a solution. I'm testing x is equal to 0 in my inequality. My inequality is 4x minus 8 over 2x plus 1 supposed to be greater than or equal to 0. I want to see if it making sense or if it not making sense. When I do my simplification, I get minus 8 is greater than or equal to 0. So ask yourself, is this making sense? Tell me in the comments there. I wouldn't receive them immediately, but I will receive them nonetheless. So tell me if this making sense. The answer is no, doesn't make sense. So this makes no sense. Right? And I'm just writing this down here because that's how we just talk. In an exam, you'll say it's not true. Now what does this mean? When I substitute 0, 0 is not a part of the solution. So now I go back to my number line and I try to figure out where is 0. When I look at my number line, 0 is in section 2. 0 ain't making sense, so section 2 ain't making sense. So I'm writing down all that. 0 is in section 2. 0 not making sense. Therefore, section 2 not making sense. And this is how the range of values occur. The range of values occur if 2 making sense, 2 is my solution. If 1 making sense, section 1, then 1 and 3 is my solutions. So 1 and 3 always go hand in hand with each other, and 2, he going by himself. Alright? So if 2 not making sense, then 1 and 3 making sense. If 3 making sense, 1 making sense. If 1 not making sense, 2 making sense. So you have to try and develop this. 1 and 3 always goes hand in hand, and 2 goes by himself. So if 2 not making sense, 1 and 3 will make sense. And you can take the time and test values in 1 and 3 and see if it making sense in the inequality. So 1 and 3 will make sense. And this is how we represent the solution. My solution, we put the curly bracket and we write down, well, it will be 1 union 3. Don't write down 1 union 3. Do not write that down. I just put in that to illustrate something. 1 will be the set of values x such that x is less than minus a half. Union the set of values x such that x is greater than 2. This is how we represent it if 1 and 3 are the solutions for my inequality. Now, in your final line, this is where you go back to your inequality nature. The nature have an equal sign attached to it, so I will attach an equal sign in my answer. That's it. Let's do another example. Let me say, let me make up a quadratic this time, right? And eventually, we will reach at this point here. We will reach at that point, and then we will go ahead and solve it from there. So first, let me get our regular quadratic. In the event that they bring a quadratic, let me say we have a quadratic that says 4x squared plus 11x plus 6 is less than or equal to 0. Right, Exodus, I now seen your comment. I don't know if it's still applying, right? Don't know if it's still applying right now, but only in the solution. Whatever the nature of the inequality sign is in my question, that will be the nature in my solution. Not necessarily the direction. Right, so for this one an example, I'm going to not put the equal sign. Right, so this one is greater than, so this one is going to be less than. So let me go ahead and factorize this here. A by C is 4 by 6, which is 24. Factors of 24 that will add to give me 11 will be 8 and 3. So 4x squared plus 8x plus 3x plus 6 is less than 0. 4x into x plus 2 plus 3 into x plus 2 is less than 0. I have x plus 2 into 4x plus 3 is less than 0. So again, I get a line that looks like the green highlighted piece. I get a line that looks like the green highlighted piece here. So what do I do from here? I let this equal to 0. Let x plus 2 into 4x plus 3 be equal to 0. So again, I'm going to erase all inequality signs from my head and I'm working fresh. I solve. X plus 2 is equal to 0. I get x is equal to minus 2. Or 4x plus 3 is equal to 0. I get x is equal to negative 3/4. I get my two solutions. I'm representing them on my number line. Draw a number line nice and long because you want enough space for your section 2. You're going to say let the number line be so by so. Minus 2 and minus 3/4. Be very, very careful when you're putting both numbers on a number line, especially when we're going to be negative numbers. Negative 3/4 comes before negative 2 going in the negative direction. This is section 1, this is section 2, and this is section 3. So if you want, you could pause the video and see if you can develop the range of values for section 1, section 2, and section 3, and play back the video whenever you're ready. So in section 1, it will be x is less than minus 2. In section 2, x is greater than minus 2, as well as x is less than minus 3/4. And in section 3, x is greater than minus 3/4. I'm going to combine the range for section 2. If x is greater than minus 2, then minus 2 will be less than x, and x is less than negative 3/4. So I have my range of values for each section. So come back to normal now. Go back up to when we live, so you could be live with the solutions. Every single time I will test x is equal to 0. Is either 0 satisfies the inequality or 0 does not satisfy the inequality. If it satisfies the inequality, figure out where 0 is on my number line, and that section will satisfy the inequality. If 0 doesn't satisfy the inequality, look at where 0 is on the number line and figure out where it doesn't satisfy, so the other two sections or the other one section will satisfy. Explaining it might be a little difficult to comprehend, but doing it is easy. When I test x is equal to 0, 4x squared plus 11x plus 6. 4x squared plus 11x, x is 0, plus 6, supposed to be less than 0. It's supposed to be less than 0. So we get 6 is less than 0. We just say is not true. So this is not true. 0 is in, where is 0? Make a guess. Take 2 seconds. Look at the number line. Make a guess. Where is 0? 0 is in section 3. 0 is in 3. So therefore, 3 is not satisfied. Like I said, if 3 not satisfied, 1 not satisfied, because they go hand in hand. So if 3 isn't satisfied, then 2 is satisfied. Therefore, 2 is satisfied. So my solution, x is such that the range of values in section 2. Minus 2 is less than x is less than negative 3/4. And the only thing I'm double checking, does my question have an equal to sign attached to it? It does not, so I do not have to put an equal to sign attached in my solution. And pretty simple, right? I see exercise section 2, you're getting it. Good. Let me do one more. Let me say we have, and we could do our next little variation here. 4, let me put 4 now. 3 minus 2x over 6x plus 11 is greater than or equal to 0. We already do greater than or equal to 0. Let me do less than or equal to 0. It really does not matter. It honestly does not matter, because the only thing this fella doing is telling me if I have to put an equal to sign or not put an equal to sign in my solution. That's the only thing that fella doing there. So we have it in the form where we had to multiply by the square of the denominator. So I had to say multiply by 6x plus 11 squared. Every single time, 3 minus 2x multiplied by 6x plus 11 squared over 6x plus 11 is less than or equal to 0 into 6x plus 11 squared. Right hand side is 0. Denominator cancels with one of them on the numerator. 3 minus 2x into 6x plus 11 is less than or equal to 0. I reach the point. Let 3 minus 2x into 6x plus 11 be equal to 0. As soon as I put an equal to sign there, ignore all previous inequality signs, working fresh. Solve. I get 3 minus 2x is equal to 0. I get 3 is equal to 2x. I get 3 over 2 is equal to x. I'm concerned with my solution. Or, make sure here, 6x plus 11 is equal to 0. 6x is minus 11 and x is minus 11 over 6. I have my two numbers, represent them on the number line, nice and long. Minus 11, 3 over 2. Let 1, 2, and 3. Try and figure it out for yourself. Pause the video, try and figure it out for yourself. And then you could just come back to the live to see where we reach. In section 1, I will have x is less than, that is minus 11 on 6, sorry. X is less than minus 11 over 6. On this piece of section 2 here, x will be greater than minus 11 over 6, which means minus 11 over 6 will be less than x, and x is less than 3 over 2, so x is less than 3 over 2. And in section 3, x is greater than 3 over 2. What we go test? We go test x is 0 every time. Nothing wrong with that. Nobody ever vex with you. We testing x is equal to 0 in the original inequality. So we gotta go back up. 3 minus 2x over 6x plus 11. 3 minus 2x over 6x plus 11 supposed to be less than or equal to 0. Less than or equal to 0. I get here 3 over 11 is less than or equal to 0. It's not making sense. Yeah? Not true. 0 is in section 2. Yeah? 0 is in section 2. So therefore, section 2 is not satisfied. Therefore, 1 and 3 is satisfied. So my solution, whenever 1 and 3 is satisfied, make sure you express your solutions properly, please. Open your curly bracket. X is such that x is less than minus 11 over 6. Union x is such that x is greater than 3 over 2. Look back in your question. My question has an equal to sign attached to it. So my solution must also have a equal to sign attached to it. Alright? Now, okay, Exodus, I see your solution is correct, but I want you to put the leftmost solution on the left-hand side. So minus 11 over 6, he come in first. I will put him first. And then put the 3 over 2, put him second. Alright? Now, it just so happened, every single question we did here, 0 wasn't satisfied. There will be cases where 0 will be satisfied. So wherever it is satisfied, if it's satisfied in 2, 2 is my solution. If it's satisfied in 1, then 1 and 3 is my solutions. Cool? And you all can try one. Try this one here. X plus 4 over x minus 2 is less than or equal to 0. Alright? Try that one. A very, very simple one. The concept is the same thing. Alright? The numbers will change, but the concept is the same exact thing every single time. Alright. Ask questions if all you want. I can always come back to this. Next, calculus. Then, SFA. We're going to do calculus in a different color now. Calculus is a big topic, right? It could be virtually impossible to explain everything in calculus. Everybody's supposed to know how to differentiate. Everybody's supposed to know how to differentiate. We'll still go it over. If I have y is equal to ax to the power n, then dy dx is equal to, I multiply by the power, and I take away 1 from the power. For example, y is equal to 3x to the power 4 plus 2x to the power 6 minus 11x squared plus 2x to the power 2 cube. I multiply by the power, 4 3s are 12, x, and I take away 1 from the power. 6 2s are 12x to the 5 minus 22x plus 6x squared. I'm going to show you how to differentiate everything. It will take way too long. We wouldn't be able to finish it anytime soon. But it's very late in the term. All you're supposed to know how to differentiate, please. When you have negative powers, when you have fractional powers, when you have root signs inside of there, when you have variables on the denominator, you need to know how to do all those things. So a quick thing, dy dx is called the gradient function. Which is used to calculate the gradient of a point at a point on a curve or a line. You could use it for a line as well, a straight line. For example, I'll jump into GeoGebra here and just delete these things I have here. Alright, we could use this one here, right? And I'm going to draw a straight line. Y is equal to 2x plus 4. Okay, cool. Now, if you look at the straight line is of the form y is mx plus c, where m is the gradient. So the gradient of this line here, the black line, is 2 for every point on the line. So if I pick a point up here, look, if I pick this point here, the gradient at this point is 2. If I pick the point here, the gradient at this point here is 2. The gradient at this point is 2. The gradient at this point is 2. The gradient at any point on the line is 2. Well, if I use calculus, if I have y is equal to 2x plus 4, I can say dy dx is equal to 2. This is the gradient at any point on the line. But if I have the next curve now, at every point on the curve, the gradient changes. The curve has equation 3x cubed plus 2x squared minus 4x plus 2. I'll cascade this here, cascade that there. 3x cubed plus 2x squared minus 4x plus 2. Well, the y dx will give me the gradient at any point on this curve, because the gradient at every point changes. Close that off. Yeah, the gradient at every point on the curve, it changes. So when I differentiate this fella here, I'll get 9x squared plus 4x take away 4. Now opposed to the one before, I no longer have a constant. I have an equation. What does this mean? This means at every point on the graph, I will have a x value and I will have a y value. For calculus, we focus in mainly on the x values. So I can say, I'm going back to my curve. I'm going to hide this here. For my straight line, when x is equal to a half, I get y is equal to 5. So that is a point on the line. So when x is a half, what is the gradient of the line? When x is a half, the gradient of the line is 2. When x is anything, the gradient of the line is 2. But when x is a half, what is the gradient of the curve? We need to figure out what the gradient of the curve is. Come back here. So I just giving you a broad example here, right? When x is equal to a, where a is any x value, it could be 4, 5, 6, 25 million, whatever a is. When x is equal to a, I could calculate what the gradient of the curve is at that point. When x is a, all you have to do is substitute that value into the equation. So I'm going to replace a with a number now. When x is equal to, let's say, 4, the y dx is 9 into 4 squared. Let me use that easier number now, 1. 9 into 1 squared plus 4 into 1 minus 4. I get 4 minus 4 is 0. So the gradient of the curve at x is equal to 1 is 9. Now, when we calculate dy dx and we go and calculate the gradient of a curve, we are actually getting the gradient of the tangent. This is equal to the gradient of the curve at x is equal to 1, at x is equal to 1. And at the same time, this is the gradient of the tangent at x is equal to 1. Because, 9 times out of 10, a question will ask you to determine the equation of the tangent to the curve at the point something something. So if I get the equation, the gradient of the tangent, I can calculate the equation of the tangent. A tangent is a straight line. So let's go ahead and calculate the equation of this tangent here. And then we will draw the equation and see if it actually touches the curve at one point only. To calculate the equation of a curve, and clip this, do whatever I want, write it down. This is important stuff. To get the equation of a line, I need at least 1 point on the line and the gradient of the line. I have the gradient of the line, which is the gradient of the tangent. I do not have a point on the line as yet. I can't get the point on the line because a point consists of an x coordinate and a y coordinate. So when x is equal to 1, I want to figure out what my y coordinate is. Y is equal to 3 into 1 cubed plus 2 into 1 squared minus 4 into 1 plus 2. I get 3 plus 2 minus 4 plus 2. 2 and 2 is 4 minus 4. I get y is equal to 3. So 1, 3 is a point on the curve. I'm going back in GeoGebra. Let me check it out and see now. The point 1, 3, brother man, here is a point on the curve. So I use the equation of the curve to get a coordinate on the curve. So the gradient, sorry, not the gradient, the equation of the tangent at the point 1, 3 will be y minus y1 is m into x minus x1. This is my x1 and my y1. Y minus y1 is equal to m, and the gradient is 9, into x minus, sorry, y minus 3. X minus x1. I rearrange in one time. Y is equal to 9x minus 9 plus 3. And y is equal to 9x minus 9 and 3 is minus 6. And obviously we say is of the form y is equal to mx plus c, where m is the gradient, is equal to 9, and c is the y-intercept, which is equal to minus 6. So I'm going to draw this now, and while I'm drawing it, tell me in the chat what we going to do, right? How we going so far, if everybody understanding. I need to know one time. So I'm going to draw the tangent now, the equation of the tangent. Y is equal to 9x minus 6. Radam bam, man, he is definitely the tangent, because it touches the point at 1 point only, which is 1, 3. Alright, so I'll wait in. Anybody have any questions so far? I see Sammy part W. What the W means, Sammy? Win? I don't know. For all calculus questions, approach it like this, where we have to calculate the equation of tangent, equation of normal, right? For the equation of a normal, and please excuse if the notes will be a little bit all over the place. I just working all over the place, right? Some good tips to know for calculus. Calculus, well, coordinate geometry and calculus. A normal is perpendicular to a tangent. Also, the product of the gradient of perpendicular lines, that's the symbol for perpendicular, is equal to minus 1. I like that side swipe, ready to mash them up tomorrow. I like that. Yeah, so the product of gradient of perpendicular lines is minus 1. So if I have the gradient of the normal multiplied by the gradient of tangent, I get minus 1. Just rearrange to get the gradient of either one. Most of the times you have the capability to calculate the gradient of the tangent first, then you will have the capability to calculate the gradient of the normal. It's just minus 1 over the gradient of the tangent. Rearrange a little bit now. Whole paper could be inequalities if it was only like that, eh? Alright. Now we have three rules we need to focus on: product rule, chain rule, and quotient rule. Alright, let me do the chain rule first, right? Now, quick thing. If I have y is equal to some expression raised to some large number, chain rule. For example, 2x plus 6 to some big number, 11. Some large number or a negative number or a fraction. Right? Chain rule. 4x minus 9 to the minus 2. Chain rule. X plus 1 to the power a half. Chain rule. Y is equal to 2x plus 1 squared. You could use the chain rule, but it's easier to expand. I'm going to use the chain rule for every single one of these here going on the road. If I show you one, I'll show you all. First thing you do, make a substitution. Let t be whatever is the expression. 2x plus 6, and I differentiate in that. I'll get dt dx is equal to 2. That's the first thing. Very, very simple. If t is equal to 2x plus 6, y becomes t to the 11, and I can differentiate this now. dy dt is 11t to the 10. From now until forever, chain rule will be dy dx is equal to dy dt multiplied by dt dx, and I want everybody to put in brackets chain rule. dy dt is 11t to the 10. dt dx is 2. 11 by 2 is 22. T to the 10. Replace t. 2x plus 6 to the power 10. I'm going to move this across a little bit. Next, let t be equal to 4x minus 9. dt dx is equal to 4. If t is equal to the brackets, y will be t to the minus 2. And I can differentiate dy dt as minus 2t to the minus 3. Again, from now until forever, the chain rule will forever be that day. Dy dt is minus 2t to the minus 3 multiplied by dt dx, which is 4, minus 2 by 4 is minus 8t to the minus 3. Replace t, minus 8 into 4x minus 9 to the minus 3. You could leave it like that. You could send the expression on the denominator. If you're comfortable doing it, go ahead and do it. If you're not comfortable doing it, leave it like this. Yeah, that's all I had to do. Exodus. That's it. That's it for chain rule. Chain rule. All them rules real easy. Real easy. Again, let t be, I'll put a bracket a, x plus 1, differentiate it, dt dx is equal to 1, y becomes t to the half, dy dt becomes 1 half t to the minus a half. Again, chain rule is that, substitute whatever I had to substitute, minus a half t to the minus a half, sorry, a half t to the minus a half, multiplied by 1, we get 1 half t to the minus a half. Again, if you're comfortable rearranging this and putting it in the form of a root, send it on the below, put it in the form of a root, go ahead. If not, leave it like this. Let t be 2x plus 1, dt dx is 2, y becomes t squared, dy dt is equal to 2t. Again, chain rule, is that brother man there? Is equal to dy dt by dt dx, that is 4t, which is 2x plus 1. That's it. While we going into the product rule, give me your thoughts on the chain rule. One note. Something else I was gonna say. Right. For the chain rule, it's important to understand when to use it by visually looking. When I visually look at an expression and I determine to differentiate something, I look at it, I have an expression raised to a mad power, a big power, negative power, or a fractional power. First thing is chain rule. Now, I have a problem with the short method, Sammy. If a question is strictly chain rule, use the substitution. The only time I will recommend you use the shortcut is if a chain rule appears inside of a product rule. Okay? Or if a chain rule appears inside of a quotient rule. If a question comes like these 4 examples here and you use the short method, you might lose some marks. Okay, but you are allowed, well, I will say, I will give you permission to use the shortcut method if it appears in a product rule or a quotient rule. Okay, Exodus, there is a shorter method to do it, but I'm not going to go through that. I'm not going to confuse nobody with that. If you're comfortable doing it, by all means, go ahead and do it. If not, use the long method every single time. If you understand the long method, better man, do it. It ain't making sense going and learning the short method and tying up yourself. So product rule. The same way how we identified when we use the chain rule, we're going to learn how to identify when to use the product rule. The product rule is used when we have y is equal to expression to power. It don't have to be to power. Multiplied by expression to power. For example, y is equal to 4x plus 6, like I said, it doesn't have to be a power, into 2x plus 3. I can use the product rule to do this here. I can also expand it out and differentiate each term by itself. Example, y is equal to 4x plus 6 to the power 3 into 2x minus 11. Again, I don't have to have a power on them, but we do have a power. This is to the power 1 and to the power 1. Okay? And we're going to do 3 examples to this one. Huh? Y is equal to 6x plus 4 to the power a half multiplied by 2x minus 3. Cool. Now, these things are easier. And while we doing this, I want to say in the comments, because I want everybody to be okay with this. I want everybody to contribute something in the chat for me right now. How comfortable everybody is changing surds to indices. For example, if I have the cube root of x plus 2 to the power of 61, how comfortable are you transitioning from this to this, x plus 2 to the power 61 over 3? I will say so in the chat right now while we do this question, so I will know if to go back and teach this again. Alright, so when we're doing the product rule, statements is very, very key. Makes life easy if you write a statement. We always say is of the form y is equal to u multiplied by v, where u is equal to 4x plus 6, and I'm differentiating this, so du dx could be 4, and v is equal to 2x plus 3, and I'm differentiating this, dv dx is equal to 2. To me, that is looking difficult at all. From now until forever, the product rule will be dy dx is equal to v du dx plus u dv dx, and we put in brackets product rule. Easy way to remember the product rule, I mean, you had to know which one comes first at the end of the day. How do we remember that? In the alphabet, A, B, C, D, E, F, G, tra-la-la-la, U, V, W, X, Y, Z. This is what I'm concerned with here. V comes after U in the alphabet. This is how I remember it. V comes after U in the alphabet. In the product rule, he comes in before. That is all. V comes before U in the product rule. That's how I just remember it. Substitute some stuff in there now. 2x plus 3. Du dx is 4. U is 4x plus 6, and the v dx is 2. 8x plus 12 plus 8x plus 12, not bad. We get 16x plus 24. Not too bad. Not too bad at all. Again, for the second example, is of the form y is equal to uv. Right, so given that everybody comfortable with that, there are questions that will come where they don't give you the expression like how nice we getting it here. So what I'm going to do for the last one, I'll change it and I'll put a square root sign over that. A question might come just like this here, so we need to know how to approach it. Is of the form uv, where u is equal to 4x plus 6 to the power 3. We have a chain rule now. We have some expression raised to a power. I mean, we can go ahead and expand it, but we have to be a little versatile. So let's go and differentiate this using the chain rule now. I'm not going to show the shortcut. Again, we let t be equal to whatever in the brackets, 4x plus 6, and we differentiate that, dt dx is 4. So u becomes t cubed, du dt is equal to 3t squared. My question, I want to know what du dx is. So du dx is equal to du dt, because I just know I calculated for a reason. I calculate du dt to use it, and I calculate the tdx to use it. An easy way to see if you're going correct, this cancels with this, and I get du dx. But don't show the cancellation, eh? But as an easy way to check and see if you're going on the right track by combining your terms to multiply in the chain rule. This is the chain rule. Du dt is 3t squared. dt dx is 4. So we get 12t squared, which is equal to 12 into 4x plus 6 squared. This is du dx. So although it's looking like a little plenty, the chain rule real easy to use. Real easy to use. And v is equal to 2x minus 11. dv dx will just be 2. I doubt CXC will bring a chain rule or a product rule. I mean a product rule or a quotient rule where you have two sets of chain rule inside of it. You see, like in this question, I have only one chain rule inside of it. If I had a mad power on top here, like 61,275,000, tra-la-la-la, I would have had to use the chain rule there. But luckily, we don't. And I don't think CXC could do that. Again, quoting the product rule. All I go have enough paper. All I go have enough paper to do this, right? Don't afraid to use space on the paper. Ask for more paper if you have to. V 2x minus 11. du dx 12 into 4x plus 6 to the power 2 plus v 2x minus 11. I'm sorry, u 4x plus 6 cubed multiplied by the v dx. Expand it out. Now this is multiplication here. Multiplication is commutative. I can multiply this 12 to the front of everything. If you want to leave it like this, you can leave it like this. If you're not comfortable in your algebra skills. If you are comfortable in your algebra skills, you could go and factorize and simplify it as much as you want. 12 into 2x minus 11 into 4x plus 6 squared plus 2 into 4x plus 6 cubed. For those of you who would like to factorize this, my common factor will be 2 into 4x plus 6 squared, and I will get 6 into 2x minus 11 plus 2 into 4x plus 6. If you're lost, ignore what I'm doing. Don't fight up. Leave your answer right here. 2 into 4x plus 6 squared into, that is 12 and 8 is 20, minus 66 plus 12, that is 4, 5, minus 54. You can leave it like that if you want. Good to go. Right, so tell me what you think on example 2 so far. Yes, it has a chain rule in it. Yes, it's a little longer, but it is easy to execute. Lastly, you know, you should get it just right by now, is of the form y is equal to uv, where u is equal to the square root of 6x plus 4. Now you all said you all comfortable transitioning from a square root sign or cube root sign or whatever the case might be to an indice. So u will be 6x plus 4 to the power of a half, a chain rule. Let t be 6x plus 4. So dt dx is 6. So u is equal to t to the half, and du dt is 1/2 t to the minus a half. I want to get du dx. That will be du dt multiplied by dt dx. I'll do a quick check. Good to go. Put in brackets the chain rule. Substitute the values in it. Du dt is 1/2 t to the minus a half. dt dx is 6. 3 t to the minus a half. 3 6x plus 4 to the minus a half. Again, if you're comfortable leaving it like this, leave it. If you are able to transition to these root signs, by all means go ahead. So I'm going to do it just for this one. If you cannot do it, don't fight up, leave it here. 3 over the square root of 6x plus 4. So that's du dx. And v is 2x minus 3. And the v dx is just 2. So again, we know what dy dx is. This is dy dx. And again, all you go have all your space. Use all your space. V was 2x minus 3 multiplied by du dx, which is 3 over the square root of 6x plus 4 plus u is the square root of 6x plus 4 by dv dx, which is 2. Now please don't multiply the 2 inside of the square root sign. The 2 is multiplied outside of the square root sign. This is equal to 3 2's are, I'll simplify this here, 6x minus 9 over the root of 6x plus 4 plus 2 root 6x plus 4. Leave it like this, you're good to go there. Questions wouldn't come where you have this kind of mad answer. I make up. I just make up and get mad answers. Right? Don't shoot me. Alright, so that is the chain rule and the product rule, kinda in a nutshell. While we do the quotient rule, thoughts and opinions on the product rule. I'll listen in the chat. Alright, product rule, when you have an expression to a power divided by an expression to a power. For example, y is equal to 2x plus 6 over 3 minus 4x. I'm just doing two examples because if you understand how to do the product rule, quotient rule is like up thing. 4x minus 9 to the power 2 over x plus 1. I wouldn't put it to the power 2 to the power 6. Right? Spice it up a little bit. Right? Same concept where we had a right statement. Was something done wrong in question 2 in the factorization, the second to last line? Something done wrong, second to last line. Squared 6 into 2x plus 11 plus, yes, this 2 not supposed to be here. Right? That 2 not supposed to be there. Alright, good looks. Good looks there, side swipe. So we get 12x and 4 is 16x. And then 66x minus 66x plus 6 is minus 16. Alright, good looks. Alright. Same thing here, writing down with statements. Is of the form y is equal to, this time is u over v, where u is equal to 2x plus 6. And it's the same procedure again. We differentiate du dx, we get 2. And v is equal to 3 minus 4x. And the v dx is equal to minus 4. The only difference with the quotient rule is the formula. dy dx. In the alphabet, u comes before v. In quotient rule and product rule, shucks, why put product there? It's quotient. In quotient rule and product rule, v comes before u. So it's v du dx, but instead of plus, we have a minus this time. Minus u dv dx all over v squared. And this is my quotient rule. Learn it. Here's your best friend. Learn it. V du dx minus u dv dx all over v squared. We could expand it up real easy. 6 minus 8x, a minus and a minus is a plus. We get plus 8x plus 24 all over 3 minus 4x squared minus 8x plus 8x, 24 and 6 is 30 over 3 minus 4x squared. I'll leave in the next one for Ollie to do. I will just put the answer for you guys at the end of this. Actually, I'm gonna put the answer for you now. So while I working on this, Ollie work on it in the same breath, and I just put in the answer. All right. So we here, just put in the answer. Cool. I just put in the answer, right? V du dx minus u dv dx all over v squared. I'm not factorizing anything, right? I'm leaving it in its raw form. If you're comfortable factorizing it, then by all means go ahead and factorize it. But just to cater for everybody, for those who cannot factorize it, I will just input the answer here and you all will work and see if I get this for dy dx. Alright, so work and see if you're getting this for dy dx. 24 into x plus 1 into 4x minus 9 to the 5. Take away 4x minus 9 to the 6 over x plus 1 squared. Explain the short way to the chain rule after. I mean, I don't mind explaining the short way, but I'd rather learn the long way and keep it like that. Because if you do it the short way and you don't understand it, but you think you understand it, you're going to make a mistake in the exam. Alright, I will just do a quick thing for that here. Shortcut to the chain rule. It's very simple, but still it's easy to make mistake. If I have y is equal to ax plus b to the power of n, treat this here as a single variable. So this is equal to n into ax plus b to the n minus 1, and I multiply by the differential of the brackets. For example, that looking confusing until you see an example, right? Y is equal to 4x plus 2 to the power of 3. I'm treating my expression as a single variable, so 3 into 4x plus 2 squared, and I multiply by the differential of the brackets, which is 4. And 4 by 3 is 12 into 4x plus 2 squared. Sum and product of roots. We didn't go through sum and product of roots. We could alpha and beta roots. We could if you want to. Easy concept, real easy concept. It's just, I'll recommend I'll just learn it off rather than understanding it at this point in time. But sum and product of roots, they usually come with 3 marks, probably in a question 2. One or two questions come in the multiple choice, but we could do it. Most important thing is to know how to manipulate your roots. That's the most important thing. I do not know if CXC will bring a question where you have to form a new equation with related roots. I'll check over the... Let me check that over now, okay? I'm gonna do an next example on this first. Y is equal to 6x squared plus 2 to the power of 4. I treat the expression like a single variable. 4 into 6x squared plus 2 cubed, and I multiply by the differential of the expression, which is 12x. Multiply by the 4, 48x into 6x squared plus 2 cubed. It is shortcut easy. Shortcut real easy. But again, if you're comfortable doing the long cut, brother man, go with your long cut, right? Alright, so let me browse through the syllabus here, and I want to see if the it's not looking for it here. Get out here, boy. Actually, somebody did send me the thing, so I'm gonna bother to look for it. Kind of lost in translation there. So let me just check the syllabus here and see if you all have to manipulate roots. Determine the nature of our roots, right? Apply the sums and product of roots to quadratics. Okay, so we don't have to form new equations. That's good. That's good. Alright, we wouldn't have to form new equations. So could you put the simplified form once factorized for the second example? Alright, yeah, that is no scene. I'll do that. Alright. So the simplified form for this here will be 4x minus 9 to the power of 5 into 24 into x plus 1 minus 4x minus 9 all over x plus 1 squared 4x minus 9 to the power 5 into 24 minus 4 is 20, and 24 plus 9 is plus 33, x plus 1 squared. Alright, and that's the quotient rule. Now while we do the next topic, tell me all your strengths on integration, because our man did say calculus. Calculus is a huge topic. Alright, as somebody asked for alpha beta roots, we could do some alpha beta roots. If we had to come back to integration, we will come back to integration. Now, alpha and beta roots, just learn this, right? If I have ax squared plus bx plus c is equal to 0, and this fella has roots alpha and beta, then the sum of the roots alpha plus beta is minus b over a, and the product of the roots alpha beta is equal to c over a. For example, 4x squared plus 8x minus 12 is equal to 0. I want to let her write down what a, b, and c is. A is 4, b is 8, and c is minus 12. The sum of the roots alpha plus beta is equal to minus b on a, which is minus 8 over 4, which is minus 2. The product of the roots alpha beta is c over a, which is minus 12 over 4, which is equal to minus 3. Alright? Side note, Jarrell, the shortcut to integration where you use a substitution, you see how for chain rule we multiply by the differential of the bracket. In integration, we will divide by the differential of the bracket. Let's say it again. For differentiation, when you have a chain rule, we will multiply by the differential of the bracket. In integration, the only change is we will just divide by the differential of the bracket. So we still add 1 to the power and divide by the power, but we also divide by the differential of the brackets. Alright, so back to this here. The hardest thing to do here is to manipulate your roots. It's very simple to read off what alpha plus beta is and what alpha beta is. But questions is asked here, they say, this is manipulating roots. Questions go come and ask here, okay, well, here was the scene. I want what 1 over alpha plus 1 over beta is. Who is that? I don't, pressure in the camp. Because the only information I can pull out from my quadratic is what alpha beta is and what alpha plus beta is. That are the only two things I can have. But little do we know, somewhere inside of this here, we have an alpha plus beta inside of there. It's to find it. We also have an alpha beta inside of there. Again, it's just to find it. Now, in every single manipulation of roots, you can either have only alpha plus betas, or you can have only alpha betas, or you can have a combination of alpha plus betas and alpha betas being hidden inside of this expression. Is to find it. There's a fraction plus a fraction. I mean, brother man, we have to add two fractions LCM. In one of these streams I showed you all the shortcut to add or subtract any two fractions. If I have a over b plus x over y, first this is equal to, I multiply this diagonal, that is ay. I keep my operation. I multiply this diagonal, that is bx, over, I multiply this horizontal, I get by. For example, a half plus a third, I multiply this diagonal, I get 2, multiply this diagonal, I get 3, multiply this horizontal, I get 6. This is 5 over 6. If we jump on my calculator, you're going to see that a half plus a third is 5 over 6. And we can do this for 1 over alpha plus 1 over beta. I multiply this diagonal, I get 1 by alpha is alpha. I multiply this diagonal, 1 by beta is beta. I multiply this horizontal, I get alpha beta. So you see how inside of 1 over alpha plus 1 over beta, somehow I figured out alpha plus beta, and I figured out what alpha beta is. Now it's just a matter of substituting what alpha plus beta is, which is minus 2, and what alpha beta is, which is minus 3. And that is 2/3. Another way, now manipulation of roots, brother man, there just be plenty. They could give you plenty. Alright? Another manipulation of roots that I see common is alpha plus beta squared. I'm not going to go through the proof unless all I want me to. Alpha plus beta squared, sorry, alpha squared plus beta squared. Too many times I see students doing this stupidness. They go come and say, sir, alpha squared plus beta squared is alpha plus beta all squared. This is wrong. I don't want to see you doing that in an exam, please. That is wrong. Alpha squared plus beta squared is equal to alpha plus beta all squared take away 2 alpha beta. Unless all I want to go through the proof, I'm not going to go through the proof. Just learn this off. Alpha plus beta is minus 2 squared minus 2 into alpha beta, which is minus 3, is 4 plus 6, and we get 10. So whenever you have any two fractions in the form of alphas and betas, LCM. This is the biggest variation I can see coming with respect to square and stuff. I don't think they're going to bring cubed. Let me do one more to just get a little comfortable. If I have alpha over beta plus beta over alpha, again, we will cross on diagonal horizontal method, right? Multiply by this horizontal, by this diagonal, sorry, I get alpha squared. By this one here, plus beta squared. This one here, alpha beta. You realize in this particular one now, I have alpha squared plus beta squared. And luckily, we could learn it. Alpha squared plus beta squared is alpha plus beta all squared. Take away 2 alpha beta over alpha beta. Don't cancel nothing, just substitute things inside of here now. Alpha plus beta is minus 2 squared minus 2 into alpha beta, which is minus 3, all over alpha beta, which is minus 3. The top worked out to be 10 over minus 3. And that's it. If they bring cubed, you're sleeping for it. I mean, cubed is not difficult. The best way to learn these things is by actually doing the proof. The proof isn't long at all. It's not long at all. If I show you the proof for alpha squared plus beta squared, you can develop the proof for alpha cubed plus beta cubed, alpha to the 4 plus beta to the 4, once you are strong in algebra. So let me show you how to do the proof for it, right? This is the proof that alpha squared plus beta squared is equal to alpha plus beta squared minus 2 alpha beta. The first hint you should get when you have to manipulate a root like this is if you see squared here, you must have a squared on top of this one here too. Alright? And then you use that knowledge to make a proof. So we already know that how this fella up in the blue here, like madness. But because it is madness, that doesn't mean we cannot use it. I'm going to use the madness and try and make sense out of it. So I'm going to try and figure out, well, why isn't it equal to alpha squared, alpha plus beta all squared? So I'm going to say, well, alpha plus beta all squared is alpha plus beta into alpha plus beta. Alpha plus beta all squared is alpha into alpha plus beta plus beta into alpha plus beta. Alpha plus beta all squared is alpha squared plus alpha beta. Well, beta by alpha is the same thing as saying alpha beta plus beta squared. Alpha plus beta all squared is alpha squared plus 2 alpha beta plus beta squared. Now if you realize, in the piece of madness that we're expanding, inside of that I have alpha squared. I will highlight it. I have a alpha squared plus beta squared. So if I just rearrange alpha plus beta all squared, take away 2 alpha beta is alpha squared plus beta squared. And that's your proof. Let me try the proof for alpha cubed plus beta cubed. Now, tell me what you think about that proof in the meantime while we do the next one. For alpha cubed plus beta cubed, yes, CXC could be overdoing it, but I want to be sure. I want to make sure all are good to go. For alpha cubed plus beta cubed, I know this is not equal to alpha plus beta all cubed. I know that, right? That is a piece of madness. But again, I'm going to use the madness to try and see what I can make sense out of it. So I'll go in and try and figure out what alpha plus beta cube is. Because I kind of seen a pattern going on here. Somewhere inside of alpha plus beta squared, I had an alpha squared plus a beta squared. So somewhere inside of alpha plus beta cubed, I will have an alpha cube plus a beta cube, and it's just rearranging and making alpha cube plus beta cube the subject of the formula. So let me see what we can do here. Make life easy. This is alpha plus beta squared multiplied by alpha plus beta. We know what alpha plus beta squared is. This is alpha squared plus 2 alpha beta plus beta squared multiplied by alpha plus beta. I'm multiplying everything by alpha first, so I'll get alpha cubed plus 2 alpha squared beta plus alpha beta squared. Then I'm multiplying everything by beta plus alpha squared beta plus 2 alpha beta squared plus beta cubed. Next, try and add like terms, bring things together, make it look nice. Alpha plus beta cubed is my alpha cubed. I see my alpha cube here, and I see my beta cube here. So I'm leaving them for that as they stand. Alpha cube plus beta cube. 2 alpha squared beta plus alpha squared beta is 3 alpha squared beta. Alpha beta squared plus 2 alpha beta squared is plus 3 alpha beta squared. Alpha plus beta cubed, alpha cubed, plus beta cubed, plus, I'm going to factorize here. I'm pulling out a 3, pulling out a alpha, pulling out a beta, and I end up with alpha plus beta. Rearrange alpha plus beta cubed, take away 3 alpha beta into alpha plus beta is equal to alpha cubed plus beta cubed. Again, if you want to learn it off. I think if CXC brings something like this, they will ask it like this. I think if they have to bring something like this, this is how they will ask it. They go ask all what alpha squared over beta plus beta squared over alpha. They go ask it like this. And they will tell you all, they will give this as a hint. Alright, you wouldn't have to prove this. They will give this as a hint. We have two fractions, multiply this way, alpha cubed, multiply this way, beta cubed, multiply this way, alpha beta. And they will give this here as the hint and say that alpha cube plus beta cube is this down here. Alright? Yes, this live is saving. You can go and re-watch it when the stream is done. Alright. And that's literally it for alpha beta roots. Like I say, 3 marks and thing, they just usually ask real simple questions. Just in case, right? Just in case. What next? Plenty. We do real plenty. Oh yeah, some other asks about integration. I'm going back in the chat. Alright, Exodus, I'm now seeing your message here. Yeah, thing. Are you gonna bother to check that? Check it over now. Check it over. 6 out of 10 for integration. Integration, big topic, you know. Integration is a real big topic. What I want to do the trigs. The trigs and the quadrants. Are you ready for trigs and quadrants? Alright, so we go take our 5, right? Literally less than 2 minutes. Bring in people. Bring in people. I don't want to go this over again. Message whoever, we're going to do the trigs. Alright? I'm going to make trigs real easy. Okay? What was done earlier? Somebody tell Shina, we do real thing earlier. We do real thing earlier. Right? Somebody tell she. Walking on sunshine. If she's a girl, I don't know. Alright? So, message all the brethren, message all the sistren, let them come in. And we're going and do trigs in about 2-3 minutes. Let me just go and get an next drink of water or something. Alright, Talia. We're back in the dance there. Let's fix this thing here real quick. Alright. I go fix that after, yes? Alright, Talia. Ready for some tricks? Now, tricks is our topic. It's nice, but you had to do it. Alright? You had to be in it. I'm gonna make tricks real simple. Proving tricks, it has no one way to prove a trick, right? There's more than one way to prove a trick. Now, we go write down the identities. I wouldn't prove no tricks. Do you all, unless all I want me to, do you all want me to prove trigs or to solve trig equations? I will make solving trig equations so simple for everybody. So simple. Whether it's in radians, whether it's in degrees. I need to know if all I want me to do trigs, solving them or proving them. Up to all you. Zoom in on more. Is this oh, I should be seeing this screen properly, ain't? Alright, no scene with the trig equations. We start in basic, real basic, right? I'm not diving in depth. I'm just showing you how to do the full thing, right? Trigs. Now, first things first, let me deal with degrees, okay? If they say to solve cosine theta minus sine theta is equal to 0, between 0 is less than or equal to theta is less than or equal to 360 degrees. Before we dive into that, I wanted to show you this. We have a quadrants. Our quadrants is what dictates where we will find our solutions. In our xy axis, we have 4 pieces cut up. We refer to this as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Sorry. Obviously, quadrant 1 is from 0 to 90, 90 to 180, 180 to 270, and 270 to 360 degrees. Our trigonometric functions behave differently in each one of these quadrants. For example, let me pick an angle in each quadrant. Let me say theta in the first quadrant is 60 degrees. Let me say theta in the second quadrant, something between 90 and 180. Let me go with 150. Let me say, again, we're just picking, right? Let me say something between 180 and 270. Let me say 240. I'm just making up. And something between 270 and 360. Let me go with 300 degrees. So we're going on the calculator and we're going to check and see what's going on in each quadrant. Remember, our 3 trig ratios are sine, cosine, and tan. First things first, my calculator is in degrees because these quadrants here, we're working with degrees first. What is sine of 60? At the end of the day, is a positive number. So I'm going to write this here. Actually, I wouldn't write it. What is cosine of 60? It's positive. What is tan of 60? It's positive. This works for all angles between 0 and 90 degrees. Between 0 and 90 degrees, and you can check it on your calculators if you want. sine, cosine, and tan are all positive. Between 90 and 180 degrees, if I have sine of 150, I get a positive answer. Cosine of 150, I get a negative answer. And tan of 150, I get a negative answer. So from first quadrant to second quadrant, I have a little change in how the functions behave. Sine is the only function that remained positive from first to second. Cosine and tan, they became negative. What about the third quadrant? Sine of 240. Look, sine going to negative now. Cosine of 240. Cosine remain negative from quadrant 2 to quadrant 3. And tan of 240. Tan changed to positive now. And lastly, in the last quadrant, sine of 300. Sine remained negative. Cosine of 300. Cosine changed to positive. And tan of 300. Tan changed to negative. Now there's an easy way to remember what happens in which quadrant, or how the trigonometric functions behave in each quadrant. And there's an acronym that we use. It's called All School Teachers COS. It's just an acronym. Don't overthink it. All means all trigs are positive in quadrant 1. In quadrant 2, sine alone is positive. In quadrant 3, tan alone is positive. And in quadrant 4, cosine alone is positive. It's very important to know how the trig functions behave in each quadrant. Now, whenever you're doing a question, I'll start off very, very basic then. Sine of theta is equal to 1/2. Whenever you're doing a trigs question, the first thing I want everybody to ask themselves, is the trigs function positive or is it negative? In this case here, I'll actually write it down. I'll say that sine theta is positive. Now, where is sine theta positive? Sine theta is positive in quadrant 1 and 2. Very, very important. So we identified that sine theta is positive in quadrant 1 and quadrant 2. Now, as a maths student, you go just say, well, theta is sine inverse of 1/2, which is correct. It is correct. But there are more than one answer for trigonometric functions. There are more than one solutions. We need to figure out all the solutions for the given domain. This fella here, our circle, is called the domain. He tells us when to stop. Now, let me say if we had another example, and we'll do both examples. This is example 1, another example here. If I have cosine of theta is √3/2, negative √3/2. First thing you ask yourself, what is cosine theta? Is it positive or is it negative? We see cosine theta is negative. So we ask ourselves, where is cosine theta negative? We know that it's positive here, and it's positive here. So therefore, it will be negative here and negative here. So cosine theta is negative in quadrant, that's 2 and 3. Excuse the little jumbling up of work, okay? So it's negative in quadrant 2 and 3. Once you can identify where the function is negative or positive, you're good to go. Now we have to learn how to calculate the angles in each of the quadrants. In the first quadrant, I have every single time, please. Every time. You have to calculate something called your principal value, abbreviated as PV. This is your principal value. Principal value. The principal value will be whatever trig ratio you're working with, whether it's sine, cosine, or tan. It will be cosine inverse of the modulus of the answer A. Let me just see. If cosine of theta is equal to A, my principal value is cos inverse of the modulus of A. So basically, we're just taking all positive values for the first quadrant. This is my principal value. In the first quadrant, theta is my principal value. Don't get too worried, and if you're confused, don't worry. When you do an example, you all will see this unfolding. In quadrant 2, theta is 180 degrees. Take away my principal value. Quadrant 3, theta is 180 degrees plus my principal value. And in quadrant 4, theta is 360 degrees minus my principal value. So with that being said, let's go and solve the first question. Sine theta is equal to a half between theta is equal to 0 and 360. Sine theta is equal to a half between 0 is less than or equal to theta is less than or equal to 360 degrees. So we already established that this trigonometric equation will have solutions in quadrant 1 and quadrant 2. Now the beauty about this method is you can do all of your calculations inside of your quadrants. First things first, remember, every single time my principal value is equal to, I'm using the sine function, so it will be sine inverse of the modulus of modulus of a half. For those of you who don't know how the modulus function works, the modulus of 1/2 is equal to 1/2. The modulus of negative a half is equal to a half. So basically, we're just changing all positives to negatives. All negatives to positives. Which is sine inverse of 1/2. What is sine inverse of a half? Let's check it and see. Sine inverse of 1/2 is 30 degrees. No problem. Once you calculate your principal value, you can calculate all your angles. We know that our solutions lie in the first quadrant and the second quadrant for this particular example. In the first quadrant, theta is my principal value. In the second quadrant, theta is 180 degrees. Take away the principal value, which is 180 degrees. Take away 30, which is 150 degrees. So if I go back and check here, if I type in sine of 30, I'm supposed to get a half, because 30 is a solution. If I type in sine of 150, I'm supposed to get a half, because 150 is a solution. But I have more answers. If I type in sine of 390 degrees, I also get a half. So 390 degrees is a solution. But where did that come from? Oh Lord. All of these, well, the sine and the cosine curves, they are called cyclic, meaning they repeat themselves every 360 degrees. So this set of values we calculate here is in our first revolution of the quadrants. I'm going back up to my quadrant here. From here to here is definitely 360 degrees. That's my first rev. If I go in our next revolution, I will now cover 720 20 degrees, and that's my second revolution. I can go again, cover my third revolution, go again, cover my fourth and fifth, and so on. So we have to keep going until we go outside of this domain that they specified. So in the second rotation, or the second revolution, theta will just be 360 degrees plus every single answer I got in my first revolution. It'll be plus the 30 degrees, and this is where we get the 390 degrees from. But out of range, because theta stops at 360 degrees. So now I can say that my solution, theta is equal to 30 degrees and 150 degrees. And that's it. Let's do the next example here. We had cosine theta is minus root 3 over 2, and I'm going to change the domain. 0 is less than or equal to theta is less than or equal to 720 degrees. So let's go. First things first, ask yourself, where is cosine negative? Cosine is definitely negative in quadrant 2 and quadrant 3. Every single time I have to calculate my principal value, because in order to get theta from this diagram here, in order to get theta, I need to know what my principal value is. So my principal value, I'm dealing with the cosine function, so I use in cosine inverse the modulus of negative root 3 over 2. Remember, I said the modular sign just changes everything negative to positive. So this will be cosine inverse of root 3 over 2 every single time. This is how we calculate the principal value every single time. We jump on the calculator. Second function, cosine inverse of root 3 over 2. Root 3 divided by 2 is that cosine inverse of the answer. We get 30 degrees, right? I make up, I know the angle, so I'm making it up to be easy, right? We will do examples where we do have such nice angles to work with. So my principal value is 30 degrees. This is my principal value, Now, my angles, my solutions lie here and here, because theta, cosine theta is negative. Since cosine theta is negative, theta is equal to 180 minus the principal value, which is 180 minus 30 degrees, which is 150 degrees, and theta is 180 degrees plus the principal value, which is 180 degrees plus 30 degrees, which is 210 degrees. We are done yet. We have to go in the next revolution. So we say in the second revolution, theta is 360 degrees plus the answers I got in the first revolution. The first answer I got was 150. So that is 360 plus 150, 510. We are going out of range as yet. We have to add the next angle, 360 plus 210. Right, notice I just added 360 to my solutions in my first revolution. 360 plus 210, 570. Again, I am going out of range as yet, so I had to go in the third revolution now. Now in the third revolution, theta will be 360 plus the answer I got in my previous revolution. So it will be 360 plus the answer I got in my previous revolution, which is 510. That is 870 degrees, which is out of range. So my solution, theta is 150 degrees, 210 degrees, 510 degrees, and 570 degrees. So give me some feedback on this here. We will be doing some more examples. I'm going to do a quadratic just now. So I will list out the 4 laws that we have to do, and we'll do a quadratic. So let me get some input from earlier while we do that now. Any questions, feel free to ask. I'll answer them to the best of my ability. How come you don't add the principal value in which quadrant? And yeah, Adam, what are you talking about? How come I don't add the principal value? Remember, you see this diagram here? This diagram tells me how to calculate theta, and I need the principal value to calculate theta. Now, in the first quadrant, this is the formulas we use to calculate theta for each respective quadrant. Now, from the time I dive into our next revolution, this here, what you're seeing on the screen right now, is my first revolution. From the time I dive into the second revolution, all I'm doing is I am adding 360 to all the solutions I got in the first revolution. The solutions are theta is equal to something. Okay? Theta is equal to something that is a solution. Only when the trigonometric ratio is positive, that's the only time where the principal value is a solution. Right, I'm not seeing here in the second in the second revolution. I'll go back down here. I'm dealing with the cosine one now, right? In the second revolution, it's just 360 plus the angle I got in my first revolution. Now remember, this angle here already caters for my principal value. I use my principal value to get that angle, so I don't have to add my principal value there again, because 150 degrees is a solution in my first quadrant. 210 in my first revolution, sorry. 210 degrees is a solution in my first revolution. To get my solutions in the second revolution, I just add 360 to the solutions in the first revolution. To get my solutions in the third revolution, I will add 360 to the solutions I got in my second revolution, and so on and so forth. I'm gonna get a past paper question here, right? Let me see how 2019 came now. What trig question we had in 2019 to do. Right, we didn't have. It was not a bad question in 2019. Right, but I will do all the variations that can come on trigs, right? Oh, if you all take note of this, in 2018, number 2 part C is a alpha beta question. So see if I could do that. 2018 2 part C is a nice alpha beta question. Right, number 4, prove the identity. Okay, good. Oh, you'll need to know double angle formulas and stuff, right? So please go and review all your double angle formulas. Sine squared theta plus 3 cosine of 2 theta is equal to 2 for 0 less than or equal to theta less than or equal to pi. So as we exposed to a new form of measuring angles, we will take it on, right? We have to learn sec, cosec for Add Maths. The only thing you have to learn for sec and cosec will be these things here, right? Like the baby identities. I call them baby identities. We actually have two more bigger identities. Here we go have one here and one here that has cosec squared and sec squared and stuff in it. But you don't have to know that for C-sec maths. You will need to know it for CAPE though. But I teach it for C-sec maths, C-sec Add Maths, sorry, because it's good exposure. You could double angle formulas too, sir. Yeah. Double angle formulas will be in your formula sheet. I'm sure there. Look. You have trigonometry. Oh no, you only get compound angle. Alright, I'll go write on the double angle then. Right, I'll write on the double angle formulas. So put in a box here. Double angle formula is important. You can just Google double angle formula and you will get a nice little sheet on it. Sine 2 theta is 2 sine theta cosine theta. Cosine 2 theta is cosine squared theta minus sine squared theta, which is equal to cos squared 2 cos squared theta minus 1, which is equal to 1 minus 2 sine squared theta. And tan 2 theta is equal to 2 tan theta over, I'm going to just double check tan 2 theta. We don't really use tan 2 theta that much, but I mean it could come tan 2x, and you go get the images, and you go see the double angle formula is 2 tan x over 1 minus tan squared x. Right, so it's just to apply them in a question. So let me go with this one here. Again, we are exposed with a pi, so that's radian measure now. So as soon as you see a pi in your question, one time, change your calculator in radians. Alright? So let me go. If I rearrange this here, I am still going to have two trigonometric expressions. I want to have one trigonometric expression to work it on my calculator. So I need to figure out a way to reduce my two trig expressions to one trig expression. Either I have all sines in there, or all cosines in there, or all tans in there. So we have the double angle formula for cosine 2 theta. So as seen, I can express cosine 2 theta in terms of sines. So I will recall that cosine 2 theta is equal to 1 minus 2 sine squared theta. So we have sine squared theta plus 3 into 1 minus 2 sine squared theta is equal to 2. And this one is a pretty easy one. Sine squared theta plus 3 take away 6 sine squared theta is equal to 2. Move the 3 across. 1 minus 6 is minus 5 sine squared theta. 2 minus 3 is minus 1. So I end up with sine squared theta is 1 over 5. If I square root both sides, I will get sine theta. And that's what I want. I get sine theta is equal to the square root of 1 over 5. but we are Add Maths students. Whenever I'm finding the square root of a number, it's always plus or minus the number. So for this particular example here, I have to consider two cases, when sine theta is positive and then when sine theta is negative. So I have two solutions here. My first solution is when sine theta is positive, the square root of 1 over 5. Well, I'm going to deal with this one as I see it. First thing I ask myself, what is sine theta? Is it positive? Is it negative? It's positive. Where is sine theta positive? Sine theta is positive in quadrant 1 and quadrant 2. That's all I need to know. So I draw my quadrants. Quadrant 1, I put in a tick because I know that is where my solutions lie. Quadrant 2, I put in a tick. That is where my solutions lie. My principal value is sine inverse the modulus of the square root of 1 over 5. Put my tick. That's sine inverse of the square root of 1 over 5. So this is my principal value, remember that. So we come in the calculator, sine inverse of the square root of 1 over 5. Now be careful when you're writing this down in your calculators, please. We get 0.4636. 0.4636. Now remember, it's in radians we are working with. Nothing else changes with respect to what I'm doing in each quadrant, what's positive in each quadrant. The only thing that changes for radians will be how I'm calculating the angles in each quadrant. So up here, I will put the radian or the radian equivalent to these things here. If your question is in radians, my first quadrant, my principal value will still be equal to theta. In my second quadrant, theta will be pi minus the principal value. In the third quadrant, theta will be pi plus the principal value. And in the last quadrant, theta will be 2 pi minus the principal value. If I put a reference for you all here, pi radians is equal to 180 degrees. So 2 pi radians I multiply by 2 is equal to 360 degrees. 3 pi I multiply by 3, 4 pi I multiply by 4, and so on. So I come back down, you all can always take a little note of this here and then follow in the solutions I'm doing down here. In my second quadrant, I know answers in my first quadrant, so theta is equal to the principal value, which is equal to 0.4636 radians. Theta is pi minus the principal value, which is pi minus 0.4636. All these things are on the calculator. Pi, take away 0.4636. 2.677. Right, I'll put 2.678. We have to go in the next revolution. In the second revolution, theta, now remember, for we degrees, in the next revolution, it's 360 plus the angles in the first. For this particular case here, it will be 2 pi plus the angles in the first, because 2 pi is the equivalent to 360 degrees. So theta will be 2 pi plus 0.4636. So 2 pi plus 0.4636. We get it 6.746. One time, this is out of range. Because the question says theta is between 0 and pi. And if we check and see, pi radians is 3.14. So once it goes over 3.14, it's out of range. Just like in degrees. It's exactly the same thing like in degrees. So we covered when sine theta is positive. What about when sine theta is negative? Remember, sine theta is negative. The square root of 1 over 5 is also a solution. Again, I jump into the quadrants here. Draw my quadrants. My principal value is equal to sine inverse of the modulus of negative the root 1 over 5. That will still be sine inverse of the root of 1 over 5. So my principal value will still be 0.4636. But my angles are no longer in quadrant 1 and quadrant 2. Remember, sine theta is negative. It's negative here and here because all school teachers cuss. And sine is positive in 1 and 2, so sine will be negative in 3 and 4. So in quadrant 3, theta will be equal to pi plus 0.4636. One time we can tell this is out of range because the domain of the question is between 0 and pi, and adding something to pi, so he will be more than pi. So I now have to stop in both cases. So my solution, theta is equal to 0. They did say give it a 1 decimal place, but I'll leave it like this: 0.4636 and 2.678 radians. Tell me. I still want to do one more with a quadratic. So give me some feedback in the chat, guys. Let me know how it's going so far. Most of them is proved, but I've seen plenty questions like this where coming where theta is obtuse and thing. Now, all I need to be comfortable with all your compound angle formula as well, please. Where the 2.6 radians come from, that's the solutions that lied in the second quadrant for when sine is positive. Remember, when sine is positive, all school, that's where sine is positive, so that's where the 2 come from. And I add it to my calculator. Pi take away that is 2.7678. Yeah, look, Navindra see it as well, from the pi minus the principal value. Jassy, you should have joined earlier. What you should do, Jassy, after this here, just go and review, go and watch back the stream. Nice one. Just watch it back, and you'll be good to go. Believe me. Who could testify if you go and watch back the stream if they're going to be good to go? Tell this man. Tell him, Jassy. Tell him if you could be good to go if you go and watch back the stream. No, how about worksheet here? I'm gonna get here for there. that. Right, there's it here. I can, how I could do this, boy? Alright, this is what I could do, right? This is available. You could find it online, but you just had to dig up for it, right? So I'll zoom in on this here for you guys. Take a screenshot of this, right? This is a good worksheet, right? These are your questions here. You have all the answers here. I'm just going to do one of them, a quadratic. I will do number I'll do number 15. Okay, I'll do number 15 and then I will go on to the next thing in tricks. So I'll write it down. Alright, so number 15. 1 plus cosine theta minus 2 sine squared theta. 1 plus cosine theta minus 2 sine squared theta is equal to 0. Now you can manipulate your stuff, guys. Manipulate your stuff. Recall that sine squared theta plus cos squared theta is equal to 1. So sine squared theta is 1 minus cos squared theta. So I have 1 plus cosine theta minus 2 into 1 minus cos squared theta is equal to 0. Expand my brackets. 1 plus cosine theta, take away 2 plus 2 cosine squared theta is equal to 0. Upon the cosine squared first. 2 cosine squared theta plus cosine theta minus 1 is equal to 0. Now, this takes the form of a quadratic. Add Maths students should be able to solve quadratics pretty simple. So we say, you could do this, it makes life a little easier. Let cosine theta be equal to y. So I have 2y squared plus y minus 1 is equal to 0. It's always recommended to make this little substitution because it makes life a little bit easier for you all to factorize it. A by c is 2 by minus 1, which is minus 2. Factors of minus 2 that will give me 1 will be 2 and minus 1. So 2y squared minus 2y, plus 2y minus y minus 1 is equal to 0. 2y into y plus 2, take away 1 into, y plus 1 into y plus 1 is equal to 0. Y plus 1 into 2y minus 1 is equal to 0. I get y is minus 1 or y is a half. So just like in the previous example, we get two sets of solutions. We get two sets of solutions over here. So let me see, we're dealing with them the exact same way we dealt with these solutions before. So if I recall, cosine theta is equal to y. So I get cosine theta is equal to minus 1. And I'll get cosine theta is equal to a half. Those are the, do you have to write the identities you use? I recommend you do, right? Although it mightn't be worth physical marks, these are the little things that will count towards your distinction. Right? So I'm going off on a little tangent here. Things that count for a distinction are, you see, when we started, we did the equation of you see this here, when you solve an equation and you put is of the form y is mx plus c, this here, you see the statement here, it's not worth any marks physically, but it is worth a mark towards your distinction. This statement here, product of gradient of perpendicular lines is -1. You wouldn't get any physical marks for it, but you get a mark towards your distinction. I mean, that is what we're aiming for. We're aiming for distinctions. Right, that is just two simple examples, right? Nice. Back to the question. First things first, I'm asking myself, what is cosine theta? Cosine theta is negative. Where is cosine theta negative? Cosine theta is negative in this quadrant here and this quadrant here. Regardless if it's positive or negative, I still need to know what my principal value is. It'll be cosine inverse of the modulus of -1, which will be cosine inverse of 1. Remember to change your calculator to degrees because we're working in degrees. Cosine inverse of 1 is 0. So my principal value is 0 degrees. Remember, theta isn't in my first quadrant. Theta is in my second quadrant. Theta is 180 degrees. Take away the principal value, 180, take away 0, which is 180 degrees. Although you know that this one will be 180 as well, you still need to show it. 180 plus 0, 180 degrees. We need to go in the next revolution. So in the second revolution, theta will be 360 plus the answer I got in my first revolution, and one time it's out of range. Also, walking on sunshine, you don't have to show in the second revolution. It might be worth marks, but it is heavily important for your mark towards a distinction. It shows that you understand there are more solutions, but the domain restricts us from doing infinite amount of calculations. So we finished for when cosine theta is equal to -1. The next solution was when y is equal to 1/2, which means cosine theta is equal to 1/2. What is cosine theta? Well, cosine theta is positive. Where is cosine theta positive? It's positive here and here. I have to calculate my principal value. It will be cosine inverse of the modulus of 1/2, which will be cosine inverse of 1/2. Go in my calculator. Cosine inverse of 1/2 is 60 degrees. Theta is in my first quadrant. It's equal to my principal value, which is equal to 60 degrees. Theta is equal to 360. Take away my principal value, which is 360. Take away 60, which is 300 degrees. We still need to show in the second revolution. Theta is 360 degrees plus the answers I got in my first revolution. One time it's out of range. So my solution, theta is equal to 180 degrees, 60 degrees, and 300 degrees. So I combine the solutions for when cosine is negative, and then I combine the solutions for when cosine is positive, and I get my answers. Tell me. Questions. I will wait and answer all questions. Good, good, okay, good. I just checking to see. I'll flip my camera. If you're watching over the video as a live, just skip forward through all of this. Right, while the comments coming in, I'm just going to put that little worksheet with the trigs. I'm going to put it on a link for you guys, right? Okay, cool. Alright, and I will share it with the chat. So it's just for you all to go and click the link and get it. So this here, bam shot. Alright, so I don't know. Just give me a sec. Right, that here. Alright, so this is it here. Good. Alright, the document should be there for you all to go ahead and download. Alright. Come on, Amir. Just go back and watch the live, that's all. When you go back and watch the live, you're gonna be good to go for the topics that we did today. Go back and watch the previous ones as well. Yeah. Ask for your extra paper. Do free to ask for your extra paper. My advice to everyone, if you have a strong point in your topics, do the questions that has those topics in them. So if you know you're not so good in your coordinate geometry, don't do the coordinate geometry first, do that last. If you know you're real strong in calculus, do the calculus questions first. Don't afraid to ask for extra paper. If you make a mistake, this is very, very, very important. If you make a mistake in your exam, do not look for your mistake, please. Scratch it off, start over. One line through the working. So for example, let me just say, right, I had made a mistake when calculating sine theta is plus or minus 1 on root 5. What I will do, I will take a pencil and I will actually just do that. That's all I'm doing. And I'm starting over my solutions here. Please do not look for your mistake. Do it over. Okay? Take my advice, please. Make sure your working is neat. Don't have the examiner looking for working that you require to have for marks. Remember, these people will be marking thousands of scripts. So them not going to dig up and fight up for a mark if it's hard to find. Make sure your working is presented in such a way that it's easy for examiner to see the work and see what you're doing. Odds are, if you did do a question wrong, you will get your error carry forward marks if your working is neat. If you made a mistake and you're working all over the place, no examiner going to look for marks to give you. So question so far, everybody good to go so far with the trigs. This is solving trigs. It have two more things we will do on trigs, which will be if you get sine theta and you have to figure out what cosine theta and tan theta is, super easy. And the last thing will be compound angle formula, which is again very, very easy, very, very applicable. Actually, I don't have to do compound angle formula. We did a compound angle formula question in the last stream, so go and look for it. It was well explained. What's a grade 1 and a distinction. So when you write your exam, you will have profiles. Your profiles, I can't remember what they are for mathematics, but you will have profiles such as comprehension, knowledge, interpretation, things like that. You'll get awarded a grade in each of your profiles. You can get a 1 with a grade A, and a grade B. A distinction is when you have all grade A's in your profile. It is not a CXC thing. I think that is a Trinidad thing. This whole distinction. Yeah, employers will look at people who have all A's in their profile, but I mean, I think in Trinidad we'll just call it a distinction. But a one is a one at the end of the day. But we want to maximize on this now, because a man go come in same grades as you, but you go have a 1B in your profile, and he go have that extra A, and he might get a walk over you. Alright, so listening. We good to go so far? Yeah, you'll see your profile in the results. When you get your results, you'll see your profiles. They just actually have knowledge, and they will have a little bracket A, B, C, or D. Interpretation, a little bracket A, B, C, or D. Comprehension, a little bracket A, B, C, or D. Alright. So, if holiday, I day, we could go longer than anticipated. We could go until after 6, but we had to take a little 5. So when I finish this here, I might just end the stream or pause the stream, and we will come back and we will resume where we left off. Alright? If all we could leave the stream running, stay on the stream, and just listen out for when we come back. Alright? So let me go. Some more trigs now. Now questions will be like this. And these questions give students pressure. But it's so easy. So easy. I really don't know how CXC does grade with respect to marks. I don't know. Probably somebody else might know. I don't know. I really can't say. I will say aim for like 80% something. 85 and up. I say 85 and up, you're real safe. You're real safe. Right, so let me go. They're going to say, if sine theta is 3 over 5 and theta is obtuse, calculate tan theta and cosine theta. So I'll go wait on all here. What is your thoughts on a question like this? Be honest. Yeah, I kind of agree with you to extend the exodus, but it also will give students a little luxury that, you know, if I had to get a 75%, they go say, alright, I'm gonna learn numbers 1, 2, 3, and 4. I ain't gonna learn nothing on number 5. If I get full marks in 1, 2, 3, 4, full marks in my SPA, and full marks in paper 1, I could leave out number 5 and number 6. But it don't work so. It don't work so at all. Leave out, leave out, leave out. This is super easy. This is easier than the trigs questions we did before. Very good, Exodus. Remember, back to basics. Back to the basics. Sine theta is opposite over hypotenuse. If I have a right angle triangle, I can actually fill out what sine theta is. And this is how you approach all questions like this. I'll draw a right angle triangle here. And I think we did a question like this in the last stream as well. If I have a right angle triangle here, I can complete sine theta. If this is theta, sine theta in the information is opposite over hypotenuse. Using Pythagoras' theorem, my hypotenuse squared is my opposite squared plus the adjacent squared. I could say let the diagram be A, B, C. So I will have BC squared is equal to AB squared plus AC squared. 5 squared is equal to 3 squared plus AC squared. 25 minus 9 is AC squared. AC will be the square root of 16. AC is 4. Now, if you want to stunt, you'll get marks. You can say AC is plus or minus 4, and then you say AC is 4 since lengths are positive, if you want to stunt. So we have this here is 4. I can figure out what tan theta is. Tan theta is, oh hell, another hour of arithmetic. It's opposite over adjacent. 3 over 4. As well as cosine theta is adjacent over hypotenuse, which is equal to 4 over 5. Final thing we have to consider is the angle. Theta is obtuse, and I will refer back to our quadrants. An obtuse angle is between 90 and 180. This is between 0 to 90. This is between 90 to 180. Remember, in this quadrant here, only sine is positive. So, if theta is obtuse, tan is negative, and cosine is negative. And that's it. That is it. Full marks for a question like this. So if they give you tan of theta is equal to some ratio, if they give you cosine theta is some ratio, this is the approach. Draw your right angle triangle. Now, just so you all know, if they say that tan theta is equal to root 3 and theta is acute, calculate sine theta and cosine theta. Now tan theta is in the form of a fraction, that's opposite over adjacent. Just know that you can put this over 1, the opposite is root 3, the adjacent is 1, and you can go ahead and find out the size of the length of the hypotenuse, which will be 2. Okay, super easy. All right, what else? Are listening? Questions, topics? I'll try my best to cover as much as I could. Exam is tomorrow. All right, trig identities. Oh yes, the SVA. We need to do that as well. Right? Quick run through. It doesn't like quick run through integration. I don't know at all. Integration is a big topic. You see how long we took to do differentiation? We took about 2 hours to do differentiation. Alright, we still have the vectors. Vectors super easy to do. So we did differentiation already, nuggets. Go back and watch back the stream and look for the differentiation from start to end. Right, displacement, velocity, and acceleration. That's SVA, SVA. It's just showing you where to integrate and where to differentiate. So I don't mind running through SVA, a quick run through, because I know you asked for it. You did ask for it, like you were one of the first students that asked me to run through something. So this is kinematics. So I'll run through SVA. If we have velocity, I'll put in SVA here. When we're going down, we are differentiating with respect to time, and when we're going up, we are integrating with respect to time. So basically, if we have S and want to get V, we are moving down. Right? I mean, I don't have to write. I could just talk and I could go and rewatch. Alright. So if I have S and I want V, I will have to differentiate S. If I have V and I want A, I'll have to differentiate V. If I have A and I want V, I will have to integrate A. If I have V and I want S, I will have to integrate V. We did past paper questions on this in the previous, I think it was day 2 and day 3. We did past paper questions on this. I think on day 1 as well, yes. No, day 1 we didn't touch the kinematics as yet. So day 2 we did kinematics. We started the class with kinematics. Day 3 we also did kinematics in day 3. Well, today is day 4. Alright, I don't mind running through the another past paper question. I don't mind. Right, we still have the vectors to do. So it's just a quick thing I'll give you all on the vectors, right? Vectors. If I want a vector AB, any vector you want, you start with the first thing in the vector and you end with the second thing in the vector. So if I want PQ, I'd start with P something plus something Q. You see this letter here and this letter here must always be the same thing all the time. Usually it's O, but that letter must be the common letter in both vectors. So what I recommend you all do is draw a diagram to illustrate this here, and I'll do a vector question afterwards. Those things are easier to do than the kinematics. 9 times out of 10 you will not have A to O. They will give you O to A. So AO, it's negative OA plus OB. Negative PO, negative OP plus OQ. And I'll do examples on this, right? The next important thing in vectors is the dot product. A dot B is the modulus of A, modulus of B, cosine theta, where theta is the angle between the two vectors. Now what is A dot B? A dot B, if A is the vector x, y, and B is the vector p, q. A dot B is I multiply the corresponding components to each other. So I'll multiply the x multiplied by p, and I'll add it to the y multiplied by q. Now we have 3 forms in which we can represent a vector. We can represent a vector in vector form or column matrix form. We can also represent a vector in ij form. If A is equal to xi plus, I'll just put numbers, yes, 2i plus 3j, and B is equal to 6i minus 12j, then A dot B, I multiply my corresponding components, so it will be 2 by 6 plus 3 by minus 12. That is 12 minus 36, and that is minus 24. When you dot two vectors, you have no units. It's just a number. Mod A will be the size of the vector, which is the square root of the I component squared plus the j component squared. So the modulus of A in this case here will be the square root of 2 squared plus 3 squared. That is 4 plus 9, and that will be the square root of 13. Same thing for the modulus of B. Now I can manipulate my dot product formula. A dot B over mod A mod B is equal to cosine theta, and theta will just be cosine inverse of A dot B over mod A mod B. So let me do a little example here, right? I'm going to draw two vectors. Let me say one vector is 11, 3. That is one vector from O to A. I'm going to put 0, 0 here. And our next vector is 4, 8. These are two vectors, right? So if I draw this on a diagram, it will look like this. You put your arrows, O to A and O to A and O to B. This is the angle made by the two vectors. Now, we can calculate that angle using the dot product. And this is what we're going to illustrate here, right? For example, if OA is equal to, and we had it as 11, 3, and OB is equal to 4, 8. Calculate the angle between vectors OA and OB. I know, see. Let me see what we can do. We know that how A dot B over mod A mod B is equal to cosine theta. Theta is A dot B over mod A mod B. Let me figure out what A dot B is. So we do have A, so I'm just going to say let A be equal to 11, 3 and B be equal to 4, 8. A dot B, I multiply each corresponding component, 11 by 4 plus 3 by 8. 44 plus 24, 4, 5, 6, 68. The size of the vector A will be the square root of my 11 squared plus 3 squared. 121 plus 9. Leave it as the square root of 130. Do not put it as a decimal as yet. The size of B will be the square root of 4 squared plus 8 squared. The square root of 16 plus 64. 6 and 1 is 7 and 1 is 8. The square root of 80. Plug these things in here. Oh, theta is cosine inverse, sorry. Theta is cosine inverse of all that big set of bacchanal. Theta is cosine inverse of this whole set of bacchanal here, 68 over mod A mod B. Jump in the calculator. 68 divided by, open bracket, the square root of 130 multiplied by the square root of 80. And then cosine inverse of the answer, 48.17938. So theta is 48.179 degrees. Back into GeoGebra here. Watch this. I want to figure out what the angle is between these two lines. Bradam bam, bradam bam. 48.1798. So the answer is correct. Wells. Right. Another important thing, I'm not gonna go through the proof, but I'll let you know if A dot B is equal to 0, then A and B are perpendicular to each other. I'm not going to the proof. If A dot B is 0, then A and B are perpendicular. This is all that has come for vectors, literally. Every time they will bring you a dot product, or to calculate the angle between the two vectors. Yeah, if you watch all the videos, I wouldn't put my head on a block and say you will be A-okay for the exam, but you will be better than how you were before, most likely. Alright, day 1, well, each stream was about 3 hours and some change. So, brother man, you gotta watch all. Alright, if you want to go through each question, I haven't put timestamps on none of the videos as yet. If you want to run through the video real quick and just skip, go ahead. Today, we focus on a lot of stuff. Alright, if somebody can just put it in the chat, I'll pin it in the chat. All the topics that we run through. Alright, so we do plenty today earlier. We do a lot today. Alright, no tricks questions should give all the problems. We will do some proofs just now. Proofs are very, very, very subjective. I will say proofs are, well, proofs is the one thing that you can do a number of ways. A number of ways. Alright? If you're writing on the topics, write it down in one line now. So I don't have to pin each individual message that you send. I'm thinking, what else? Let me just raise my volume a little bit here. No, you cannot choose questions on the paper, Jarrell. You had to pull out all-nighter for Add Maths. Well, you're way too late. I was there at one point in time. I was there. If you have a full SBA, that is very, very, very good. Do not, please, if you have a good SBA mark, don't waste that. Alright? Don't waste it. You don't want to fail this and have to write it over. The only way you could use back your SBA mark is if you repeat Form 5 in the same school. Alright? Actually, I think you can use it back if you go in a different institution. If you're doing it privately, I don't think you could use back your SBA mark. I do not think so. So please don't waste all your SBA mark if you get a good mark. If you had to pull the all-nighter, pull it, just make sure you don't crash. Oh, I can't pin comments as yet. Alright, but look, Exodus put all the topics we did so far. $53.53. No, my calculations are correct. I checked it over on GeoGebra as well. Look, the angle made between the two vectors is 48.17983. Now what you should do, be careful with your calculator. Make sure and use your brackets on your calculator. So work out what this number is first. Work out what the denominator is. The denominator is 130, the root of 130 multiplied by the root of 80. So work that out. Square root of 130 multiplied by the square root of 80. You get that? In all calculators, you can use this answer in the next calculation. See how my answer is in green here? I'll maximize this. My answer here is in green. The same way, your answer will be in a certain color. To use this green, we need to press alpha first. So it was 68 divided by that. So 68 divided by the answer equals, and then it's cosine inverse of this answer. Cosine inverse of the answer. You get that? Yes, this means we have to do probability and statistics. I am not a big fan of probability and statistics. It is a tedious topic to teach. Alright? It is very, very difficult to teach, at least for me. There are other teachers who can teach it extremely, extremely good. I mean, I can teach it good, but not as good as I want to. There are 7 questions in the paper. Let me tell you how the structure of the paper will be coming. Alright, so question 1 on your new papers will be algebra, sequences and series. Right, that's section 1, right? Number 1 is remainder and factor. Number 2 is discriminant. Well, still on number 1, sorry. Remainder and factor. Discriminant. Completing the square. Number 2 is logs and inequalities and APs and GPs. Number 3 is circles and coordinate geometry with vectors and a little bit of trigs. Number 4 is calculus, differential calculus in combination with a little bit of kinematics. Number 5 is integral calculus with a little bit of kinematics. And number 6 is probability and statistics. So there are 6 questions on your exam. Alright, so here was the scene earlier. We take our 5, right? We have been doing a lot. I will end this stream and I will start back this another stream at about 7 o'clock, 8 o'clock, and we'll do some more work from there now. If anybody has any questions or queries, no problem. 793-4754. Feel free, just message me, right? Wherever I can help, I will. If I had to send you a little bit of notes, I'm gonna send you a little bit of notes. And yeah, make sure and subscribe, like, and we will see each other in a little bit. Right? Go and take a eat, take a little bit, drink a little tea, rattle your brain a little bit, relax, and we there again tonight. So I'll see everyone in a little bit.